I will open the floor for homework questions. Yes, sir.
39.
Number 39. Number 39 gave you a building that was in the shape of an upside down absolute value, correct? 40. 40 gave you an equation for the amount of snow falling outside over the course of a snowstorm, correct? Okay. And the equation in number 40 was y equals negative 1/2 times the absolute value of x minus 4, then plus 2, correct? Okay. Part A said you needed to graph said equation. Yes? Okay. So if I graph said equation, that's going to graph with a vertex at the point 4, 2, and then it's going to go like that and like that. Yes? Okay. Then part B said, at what time during the storm was the snowfall the heaviest? Okay. Well, that's going to be 4 hours into the storm. Okay? Because that's where the snowfall, the blue line represents how much snow is falling, and that's when the blue line is at its highest point, is 4 hours into the storm. Okay? Then a follow-up question to that was, what rate is the snow falling at that time? And the snow is falling at 2 inches per hour at that point in time. Then it followed up that follow-up question with another question that said, how do those values relate back to your function? And those values are your h and your k in your function. The time is your h in the function. The snowfall rate is the k in the function. Okay? And then it lastly said in part C, if you take the area of that triangle, that will tell you how much total snow fell over the course of the storm. Well, it's a triangle, and it goes through the origin, and it goes through 8, 0. So that tells me that the base is 8. This tells me that the height is 2. 1/2 times 8 times 2, 1/2 base times height, gives me 8 total inches of snow fell in the storm. Okay? Other questions? Yes, ma'am. Number 39 gave you a building that was in the shape of a absolute value graph. Now, luckily for them, that building was an upside down absolute value one. And so it went through the origin. It went through the point 69, 140, and it went through the point 138, 0, if I'm not mistaken. Okay? So this point up here is important because that's my h and that's my k, because that's the vertex of the function, right? And then the only other thing is that I need to find the slope of my right side. And that's going to be 140 minus 0 over 69 minus 138. So that's going to be 140 over negative 69. And I can leave it like that. Okay? And that's important because that is my A value. So now I can go and I can say, well, my function, my building, is negative 140 over 69 times the absolute value of x minus 69 plus 140. Lyons, did you have a question? I thought I saw your hand. Sorry. Other questions? Seeing and hearing none. Andrew, were those the two questions you were going to ask too?
Yeah.
I figured they were because those were the two questions that I've been asked all day. Okay? So there is a stapler over there on the desk and on the cart, and then the turn-in folder is up here. All right. So today we are going to be graphing absolute value and linear inequalities. Okay? So far in this chapter, we've been graphing equalities, and so that's why it's just been lines and then absolute value v's. Okay? But now we're going to go with inequalities, so now our answers have expanded, meaning we don't just have a line or a v on our graph anymore. Now we've got to represent a set of all points that make that equation or that expression work. Okay? So there are two things that we need to remember when we are dealing with when we're dealing with graphing inequalities. The first thing that we have to remember is we have to remember the solid or dashed line rule. Okay? So the solid line happens when we are in the less than or equal to or greater than or equal to case. It's got that equals component. That's going to be a solid line. The dashed line occurs when we are dealing with just less than or greater than. Now, it's going to happen that you're going to do a graph, and then you're going to go, oh, it was supposed to be dashed, and you drew it solid. Okay? But luckily for you, you're doing it in pencil, so you can just erase and make your line dash. Okay? It happens to me all the time. And usually it happens when I'm making an answer key, and that's when I'm writing in pen. And then I go, grr. Okay? Because then I got to start over again. Okay? So it still happens. You going to make it, Freddie? Grr. Did you ever go grr? Well, yeah, because you get all mad. Usually I throw stuff, but I didn't want to throw anything today. Okay? Then the second thing that you have to remember is you've got to remember that you need to shade one side of your graph. Okay? Or if it's an absolute value v, you have to shade inside or the outside. Okay? Because the shading indicates all of the points that make the inequality true. Okay? So I am a big proponent of, whoa, that went way far, of test points. Okay? Now, the one rule about test points is that your test point cannot be on the line. Or it cannot be on the V. It has to be off of the V. Okay, or off of the line. Now, the nice thing is there are 3 simple test points. You only need to test one of them. Okay? All 3 of them can't be on your line. Those three are the origin. That's going to be your go-to one. That's the one that you want to test. Okay? Another one is going to be 1, 0. And your last one is going to be 0, 1. Okay? Your line or your V cannot go through all three of those at the same time. So that's going to be, one of those three is probably going to be your best test point. But your test point can be anywhere that you want it to be. Okay? What you do then is you put your test point into your original equation. Or I should say not equation, inequality. Okay? So you're going to plug that back into your original inequality. If when you do that, you get a true statement, you are going to shade on that side of your line. So whatever side of your line the test point's on, that's the side that you want to shade because you just got a true statement. If you get a false statement, you are going to shade the opposite side. It looks too much like a P. It looks too much like shape. Let's get a little practice in terms of testing test points. Okay? So, tell whether the given ordered pairs are solutions to the inequality. I'll do number 1. You can do number 2 here. Okay? So, number 1 says we need to test 0, 0. So I'm going to put in 0, 0 into my inequality. Y is 0, less than or equal to 2 times 0 plus 4. 2 times 0 is 0, plus 4 is 4, so I get the inequality 0 is less than or equal to 4. That is a true statement. 4 is bigger than 0. So therefore, 0, 0 is a solution to this inequality. Now we've got to test negative 2, 10. So I'm going to plug in 10 for y, less than or equal to 2 times negative 2 plus 4. Negative 2 times 2 is negative 4, plus 4 is 0, so I get the inequality 10 is less than or equal to 0. And that is a false statement. So therefore, negative 2, 10 is not a solution to my inequality. Okay. You try number 2. So, origin first, 2 times 0 minus 0 less than 3. That gives me 0 is less than 3. That is a true statement. So the origin is a solution. Negative 2 comma 2 is going to be 2 times negative 2 minus 2 less than 3. Negative 4 minus 2 is negative 6 is less than 3. That is also a true statement. So that one is a solution. So in this case, they both are solutions. Yes? Yes, ma'am. Don't change it. Makes it simpler, right? You don't want it, I know what you're saying. What if you made it y is greater than 2x minus 3? Because then you're multiplying by that negative sign, and that, remember, that flips the sign, and we don't always remember that that flips the sign. You know what I mean? Yeah. Okay? That's why we always go back when we're testing something, Freddie. Always go back to the original one. Okay? So, let's put this to work now. So the first thing that we are going to do is we are going to turn the inequality into an equal sign. So we're going to make it be an equal sign. We're going to think and graph this as if it were y equals negative 1/2 x minus 3. Okay? But when I do that, I'm going to remember my solid or dashed lines rule. Okay? So in this particular case, is it going to be a solid or is it going to be a dashed line? It's going to be solid because we have the equals component with it. Okay? So I need to graph here y equals negative 1/2 x minus 3. Okay? So that tells me I'm going to have a y-intercept of 0, negative 3, which is down 3 from the origin. The slope of my line is going to be negative 1/2, which means from that point I'm going to go down 1 and right 2. And I'm going to rinse, lather, and repeat that. And I'm also going to go up 1 and left 2. And I am going to rinse, lather, and repeat that one too. Then I can draw in my line. I like it out front better. Come on now. Give me back to my line. There it is. Order. Bring it to me. Yeah, I like that better. Okay. Then I'm going to test a point. Which is kind of like testify, but I'm going to test a point. The point that I'm going to choose in this case, what's the easiest point to choose? The origin. Yep, I'm going to choose the origin here. I also put a little T on my test point. Okay? That's just a little thing that I do also. Then I know which side my test point was on. Okay? So if I put in the origin, that's going to be 0 is greater than or equal to negative 1/2 times 0 minus 3. So that's going to be 0 is greater than or equal to negative 3. Is that a true or a false statement? That is a true statement. So now, when I go to shade, I'm going to shade on the same side as my test point. Then if we really wanted to make it, we would send that one to the back. See there, we got a nice clean line. Okay. Try those two on your own. Second one, I am so that is 4. There and there. But this one now is a dashed line. Still didn't go through the origin, so I can still use the origin. And I get 3 times 0 plus 0 greater than negative 4. 0 greater than negative 4. That is true. Let's go with whatever these are. These are flowers. It's struggling to keep up with me, with my flower power. There we go. Okay. Yes, okay. Now, just when you have all the answers, I go and I change the question. So, how do we do this one? What do you do? Do it the exact same way, right? Okay. So first thing, you're going to think y equals absolute value of x minus 1, then plus 4. What can you tell me about that? Vertex is at the point 1, 4. Right side slope. Left side slope. Negative 1. Okay? So let's go over here. 1, 2, 3, and 4. Right side slope is 1. Left side slope is negative 1. Solid or dashed? Dashed. Oh, that's way small. We gotta make that bigger. Put a little meat on that one. Okay. And then okay. Then what do you do next? Test point. Do we go through the origin? No. Origin's way down here. Okay. So we can test the origin. 0 is greater than the absolute value of 0 minus 1 plus 4. 0 minus 1 is negative 1. The absolute value of negative 1 is 1. 1 plus 4 is 5. Is 0 greater than 5? No, that is false. So instead of shading outside, I shade inside. Okay? Try that one. This one's a solid line. I did not go through the origin, contrary to what Freddie thinks. So we got 0 less than or equal to negative 2 times the absolute value of 0 minus 3 plus 2. So that's going to be 0 minus 3 is negative 3. Absolute value is 3 times negative 2 is negative 6 plus 2 is negative 4. That then yields me a false statement. So I'm going to have to shade the inside because my test point was on the outside. So I'm going to have to shade the inside. I don't think I used this one. I don't know what this one is. Oh, look at that. It's under the creative pen.
Yeah, Smartboard has always had that.
I have no idea what those are. I'm going to go with snowflakes. Okay. One last one for you guys to do. Go for it. This one is dashed. The cool part about this is you can be as creative as you want when it comes to your homework. You can artify your homework for me. Zero plus 4 is 4. Absolute value of 4 is 4. Times 1/2 is 2. That's going to give me a true statement. So that means we are going to be on the outside of the absolute value. Like you guys, superstars. Okay? Now, I'm about to give you 2 pieces of graph paper each because this homework here, this one right here, is due tomorrow. So that one is due on Good Buddy Day. Tomorrow's already Good Buddy Day. Okay? 10-4, good buddy. This one is due on day after Good Buddy Day. Okay?